What we're now going to look at is how to solve problems that have logarithms in them or exponential functions in them. To solve for x, the missing variable. We have seen in previous sections a number of rules that can help us get there, and so now we're going to put those together to actually solve some problems. So note at the top it says, if you had 5 to the x equals 125, you can make the basis the same. So 5 to the x becomes equal to 5 cubed, and therefore x has to be 3 because that's the only way that you can make the two equal. On the other hand, if you had something like 5 to the x equals 12, there's no way to write 12 in terms of 5 to some exponent, and therefore we can't solve it the same way. However, if we took the log of both sides, so log of 5 to the x and log of 12, x being in an exponent position in that equation can be brought out front using the power rule, and then we can divide both sides by the log 5 and in fact get our answer. Likewise, the second example here, solve 25, 2x plus 1 equals 15. Again, we take log of both sides, bring the 2x plus 1 exponent out front, and then divide both sides by the log 25, and now we have 2x plus 1 equals 0.8413. Solving for x, we get x equals negative 0.07935. And we could check, because we could take and plug that in for x, and then get our answer for our problem. Second example, solve x equals log base 2 of 5. We can use the change of base formula. Note that when we do the change of base, how the part that's out front goes on top, the base part goes to the bottom. These are now both log base 10 because we did not actually see any base written there. And so using our calculator, log 5 gets us 0.6990, log 2 gets us 0.3010, and dividing we get our answer. We can also do this with the natural log function, ln x equals 5. Remember that ln is the inverse of e to the x, and so in this case we make the ln x and the 5 be the exponents with the base e, and since e to the ln x is just equal to x because they're inverses, we now have x equals e to the 5th power, which is 148.4. So, some examples. Let's go ahead and solve some problems now. So, first off, we have x equals log base 8 of 2, which we can rewrite in exponent form. And so we have 2 equals 8 to the x. So notice how the 2 went on this side, the 8 stayed the base, the x became the exponent form. Now 8, of course, can be written as 2 cubed. So now we have the same bases, and of course when we have exponent parentheses exponent, that's a multiply for exponents, and so this equals 2 to the 3x. And so now I have 2, which, even though it's maybe not obvious, we can always say the exponent's 1 if it's not there, and then 2 to the 3x, and the only way that that works is 1 has to equal 3x for this equation to be true, and therefore x equals 1/3. Alright, problem 2. Now we've put the x in a slightly different form. Notice that it's at the base position, whereas before it was over here on the other side of the equal sign. Okay, we can still go to the exponent form. So in this case, the 8 will be equal to the x squared. So again, comparing these two, note how what was the log that went on the other side of the equal sign. The bases in both cases stayed the same, and what was on the other side of the equal sign became the exponent. And so now I have 8 equals x squared. That's, and again, in both these cases, that's my exponential form. Log form, exponential form, but now we can go ahead and solve. And so x is going to equal the square root of 8, and that will be then reduced to 2 root 2. Please note that I didn't do plus or minus because this can't be negative, because we're talking about the base in this case, and the base has to be greater than 0. Our x in this case is the base. Now, another way that we could have looked at this is we could have done change of base. And so in that case, we could have said 2 equals log 8 over log x. And then rearrange that to have log x equals log 8 over 2. The 2 is not part of the log, so it's really log of 8, and then divide that by 2. That we can use our calculator for and find that that is 0.4515. And then remember that log is base 10, and so the inverse is 10 to the x. And so if I go 10 to the log x, which will equal x, that has to also equal 10 to the 0.4515, which equals 2.8284, which is the same thing as 2 root 2. Root 2 is 1.414, and so doubling, we get our 2.8284. So 2 different ways that could have been used to solve this problem. Okay, problem 3. Here we have 2 logs, both base 3 equals 1. Since this is an add, we can turn that into the product rule for logs. So log base 3 of 3x equals 1. And of course this can only be done if the bases are the same. So now that's my log form, and I can turn that into exponent form. 3x equals 3 to the 1. And again, that's my exponent form. And of course 3 to the 3x, we have 3x equals 3, so x is 1. Problem 4 is a similar problem. We have plus, and so we can use the product rule. So here I'll have log base 4 of x times x plus 6 equals 2. Now let's go to our exponent form. And so that will be x times x plus 6 equals 4 squared. And going ahead and distributing, we can end up with x squared plus 6x subtract 16 equals 0. So please note, x times x, that gives us the x squared, x times the 6, there's our 6x, 4 squared, that's 16, brought it on the other side, and so we have a subtract. This can be factored into x plus 8 times x subtract 2. However, we can immediately throw out this one, because you can't take the log of a negative number and note, if this was solving for x and we went back up here, we would be taking log base 4 of x. That x cannot be negative. So that just gives us then x minus 2 equals 0, or x equals 2 for our answer. By the way, we can plug it back in to check. Over here we would have log base 4. In fact, let me go ahead and do that on the other side for a moment by plugging in the various parts. So we started with log base 4 of x plus log base 4 of x plus 6. That equals 2. Now, we just said the answer is 2. So log base 4 of 2 plus log base 4 of 2 plus 6, which of course is 8. Now, this one, remember that that 2 is the square root of 4, and so I can write that as 4 to the 1/2. Remember, the exponent of 1/2 is the same as square root. Over here, I would have log base 4. Now that's 8. Okay, 8 is 4 times 2. Okay, which means that basically I have a 4 times a 4 to the 1/2 equals 2. This, of course, is just going to be 1/2. Here, 4 times 4, well, that's 4 to the 1 times 4 to the 1/2, so that's 4 to the 3/2. And again, 4 and 4, so it's just the exponent, 1/2 plus 3/2, and that, of course, is 2. So plugging in the number, you're not required to do that, but plugging in the number, you can see that, in fact, it does give you the right answer. Not to mention, it also shows you one of the log rules, that if the base and the value of what you're taking the log of match, then whatever is the exponent is what that can be simplified to. All right, continuing on, let's look at problem 5 now. We have ln 2x plus 5 equals ln 6x minus 3. Now, I have ln on both sides. I can just take those away and end up with 2x plus 5 equals 6x minus 1. Now, I'm not really trying to do an operation here. It's just the only way that these can be true, since I'm doing ln on both sides, is if what's inside the argument of ln, in both cases, those have to be equal. And so just take them away. And now I can go ahead and simplify, subtract the 2x from both sides. I have 4x. Add 1 to both sides. I have 6. And so x will equal 6 over 4, which is, of course, 3/2. So x equals 3/2. And yeah, 1.5 is fine as well. Number 6 here, I have a subtract, so that means a division rule for my logs. So I can rewrite this as log base 2 of 9x plus 50 over 2x plus 5, has to equal 5. Now this is the log form, so I can immediately go to the exponent form, and I will have 9x plus 50 over 2x plus 5, and that has to equal the base 2 to the 5th power. So the 2, 2, 5 goes into the exponent. And now I can go ahead and simplify. So 9x plus 50 is going to equal 2 to the 5th is 32. And get rid of my fractions by multiplying both sides by the 2x plus 5. Then we can simplify this into 64. This part here will equal 64x, 32 times the 2x, plus 160. And now in simplifying this part here, the 9 and the 64, so I'm going to end up with basically 55x, and actually since I moved it to this side it would be a negative 55x, and then moving the 50 to the other side I have 110, and so that leads to x equals negative 2. Now in a couple of cases before we said, well, x can't be negative, but it depends where the x is and what the result of that negative number is. So up here, if we actually look at the problem, we don't have log base 2 of negative 2. In this case here, we'll have 9 times the negative 2, which will give me negative 18 plus 50. So that'll be 32. That's still positive. And over here I'll have 2 times negative 2, which would be negative 4. Negative 4 plus 5, well, that would be 1. And so that again would be a positive number. And so in that case we could do things. So sometimes we throw things out because it would be negative. We're not allowed to do it. But in other cases we can have a negative number. Alright, now we're going to look at some in which we do change of bases to help us do things. So first off, we have 4 to the x equals 3. There's no way to rewrite the 3 in terms of an exponent of 4. So I'm just going to take the log of both sides. Then move that exponent out front. And again, since I'm not writing any base, that means the base has to be base 10, and I can use my calculator for it. So now I'm going to divide both sides by the log 4. And then using my calculator, log 3 gives me 0.4771. Log 4 gives me 0.6021, and I get an answer of 0.7925. Now, problem 8, similar problem. I'm going to solve it the same way. And so log of 3 to the x equals log of 4. Again, I just took the log base 10 of both sides. That then, of course, becomes x log of 3 equals log of 4. And then x will equal log 4 over log 3. And you know, note this is the same thing I had before, except I have the reciprocal this time. So it's still going to be the 0.6021, but now that's on top, the 0.4771 on the bottom, and I end up with x equals 1.2619. And of course, if I were to take this one and do 1 over If I were to go x equals 1 over 1.2619, I would get 0.7925. They are reciprocals of each other. And so there I have problem 8. Okay, problem 9. In this case, I can go to common base. 9x plus 1 equals 9 to the 1/2. Again, exponent of 1/2 is doing square root. The square root of 9 would be 3. Now that I have the bases the same, I can go x plus 1 equals 1/2, and therefore x equals negative 1/2 when I subtract 1 from both sides. It really, I don't have any rules when it comes to just the exponents in terms of having positive or negative answers. Alright, same thing. Now I switch the 3 and the 9. So let me do 3 to the x minus 1 equals 3 squared. Therefore, x minus 1 equals 2. Therefore, x equals 3 as my answer. And so, no matter where the x was, we could, in fact, solve the problem.